Hello, everyone, and welcome to another episode of Open Observability Talk. Here at Open Observability Talk, we talk about anything DevOps, observability, and open source. So, as I always say, may the open source be with you. And for those joining us on the live stream on YouTube or Twitch, feel free to share questions and comments on the chat. Definitely a great opportunity to do that with the experts that we have here on the show. And with that, let's move on to today's episode. I've been following ClickHouse, open source database, for some time. It caught my attention with pretty impressive performance benchmarks and high-profile companies choosing it, like Shopify, actually, that I hosted here on the show recently. And lately, I saw a fascinating project that takes ClickHouse to a whole new level by matching it with Apache Iceberg data lake in a new open source project launched by Altinity. So I invited Robert Hodges, the CEO of Altinity, major ClickHouse maintainers on the open source project, to give us a run through the latest and greatest with ClickHouse, as well as this fascinating new project. Hey, Robert, good morning.
Hi, Dotan. Glad to be on.
Yeah, thanks for joining me, and great opportunity. Really hot news there off the wire that we're going to talk about today. And as I said, you're a CEO, so maybe you're used to elevator pitches. So give me the elevator pitch on ClickHouse and why people should know.
Well, here's a simple reason you should use ClickHouse. You have a lot of data, it's arriving really quickly, and you want to get answers out of it equally quickly. Imagine you're a security manager and you want to make sure if somebody's hacking into your machines. So you're collecting measurements on all your machinery. You may be using software to do this. You may be a vendor that's actually implementing this as a platform. You're just going to stream this stuff in, put it into a database. When something interesting happens that violates your rules, you want to detect it in as close to a few seconds as possible. And then you want the ability to go in and ask quick questions that you may not have thought of in advance to find out how serious is this problem, when did it happen, what's the scope, so on and so forth. Anytime you get an application that has that property, ClickHouse is a great database to use.
Sounds good. And the operative word here is speed. I hear that and that's
Really?
definitely a key trait that we're going to delve into.
Right.
But you've been around the databases around for decades now.
Decades, yes.
You're not stranger to databases. So maybe tell us a bit about yourself and how you ended up with the ClickHouse open source database.
Yeah, sure. Well, just how I got into databases, I was in the military many years ago, and they introduced a database called M204, which is a little bit organized, a little bit like Elastic, of all things. But anyway, this was the coolest piece of software I'd ever seen. It ran on IBM mainframes. It was written in assembler, and I thought, I want to work on this thing. I even tried to get a job with the company after I got out of the military. It didn't work. But what that did set me on was working on databases, which I eventually got a job at Sybase back in the 90s, worked other jobs. And about 7 or 8 years ago, a good friend of mine told me, hey, there's this interesting database that that you ought to have a look at. It's called ClickHouse. It's new, it's open source, because he also knew I'd worked on a lot of open source databases. You should check it out. And eventually I did. And I liked it so much that I ended up joining a company that he was starting called Altinity. And I've been working on it ever since. So I've been working on ClickHouse now for about 6.5 years.
Amazing. And we should say Altinity is the second largest maintainer contributor to the open source project, right?
That's correct. And not just to the project, but to a lot of the ecosystem projects. So for example, if you run ClickHouse on Kubernetes, it's probably about a 90% chance that you're using our Altinity operator for ClickHouse. It's used by thousands of companies worldwide. We also do the ClickHouse backup, which is a very popular backup tool, and there's a number of other projects. So yeah, we do, and then we do hundreds and hundreds of commits to ClickHouse.
Yeah, it's a vast ecosystem, and definitely let's spend some time on that as well.
Absolutely.
But first, you gave us the elevator pitch in terms of the benefit, but our audience is technical, and I know that although you're a CEO, you're a very technical CEO, I can say from our chats so far. So a bit about like what it is. Like we know it's OLAP, it's a columnar. Give us the technical overview of what it is about.
Yeah, I think a really simple way to do that is to go back and say, well, why was ClickHouse written in the first place? So the genesis of ClickHouse was at Yandex, which is a very well-known company. They do hosting, they do web analytics, and they had a product called Metrica, which is very similar to Google Analytics. So it allows you to collect information on visits to your pages and then go analyze them. Like how long did people stay on pages? Which page did they visit the most? What was their bounce rate? Construct funnels where you can look at, like, behavior over a succession of pages. And they were using MySQL to store the data and then run queries on it. And the problem that they ran into once this application became popular was MySQL simply couldn't handle the load. And the reason is that MySQL does two things which are not very good for analyzing large amounts of data. One is it stores it in rows. So if you have a big table that's got, say, 20 columns in it, and you decide, hey, I want to ask a question that uses two columns, you have to read every single column. So you end up reading a huge amount of extra data. The second thing.
Not to mention aggregations.
Yes,
And
exactly, to do aggregation. So like you're doing a sum or you're doing counts across every single row in the database. Not an uncommon question. MySQL is terribly, terribly slow on that because you end up reading the entire database, or the entire table. The second thing is MySQL at that time, and I think even still today, uses a single thread to do this. So it's sort of adding insult to injury. And so what they ended up doing was they ended up pre-aggregating, which means you're basically guessing the questions that people are going to ask. You run a batch job that creates tables that have the answers all loaded up and ready to query. And at some point, this just became unsustainable. So Alexei Milovidov wrote a simple query engine that arranged the data in columns, and it was basically just a report generator that um, I I haven't ever seen what it looked like, but I think it had a little stub of SQL, but it could basically answer these questions without having to pre-aggregate the data, and it did so by having columns and by having multiple threads uh, scanning those columns. And those two things are what or why ClickHouse became big. In fact, why analytic databases in general are very popular. They store the data in columns, so it's ideally structured for reads, and they query it in parallel. Those two things then lead to some other knock-on effects, like the fact that if data is stored in columns, it's like arrays, and it compresses better. It also makes it easier to parallelize it uh, in very good ways. You can use things like SIMD instructions because you're scanning the same data types. Um, so a bunch of things followed from that. That's how ClickHouse started, and that's why it's and of the there are many databases that do this, but of those, ClickHouse is probably the best one today. Certainly the best one in open source.
actually, it's interesting. We've seen sort of a proliferation in a certain period for columnar databases, and in a way, it also aligned with the trend around NoSQL. We started seeing
Yeah,
lots of I still remember, and you probably remember it better than me, that the days where that one size fits all, and everyone went to
yeah,
Oracle, to MySQL, to
yep,
Postgres, and then suddenly the shift turned to the other extreme where you had there was no SQL on the one hand, and then on the other hand there were so many specialized databases. We see that till this day. So you have vector database
mhm,
and graph database and
right.
columnar and whatnot. And I'm actually curious, taking a step back and zooming out with your vast perspective on the database evolution. How do you see this transition? Where are we on this path?
Yeah, I think that there's two things that are driving this cornucopia of databases, or you might almost call it like a Cambrian explosion that occurred kind of toward the end of the 90s. Um, and those two things are, first of all, the layout of the data. So I have this thing that I call the fundamental theorem of data, that if you're thinking about performance, you're thinking about what makes a database fast, the number one thing is how the data's laid out. Is it laid out in a way that helps you answer questions or do operations quickly? If it's not, you're screwed. So that layout of the data, and then secondly, the access patterns. Graph databases ask particular types of questions where they're basically recursively traversing graphs to build paths. That's very different from a database like MySQL, which is maybe maintaining a basket that somebody's holding as they're as they're traversing an e-commerce site. And that is yet again very different from something like ClickHouse, which might be storing trillions of rows of market data that's just waiting there for some analyst to come in and pick tranches of it to develop trading strategies. So the size of the data and then the way you're accessing it, the algorithms that you're implementing, those are the two things that are driving this. And of these two, the thing that's really significant is the data size has just increased enormously. And I think that was what the breakout to NoSQL, people got really obsessed with the fact that MySQL, or excuse me, that SQL was somehow broken. But I think what was really happening was the data was becoming larger than could fit on a single machine. At that point, you're talking distributed data. And some of the things that you put into SQL, like transactions, become a lot harder to do when the data is spread across multiple machines. You can't hold locks, or if you hold them, they're very expensive. There's a bunch of, and so that's where you started to see this flowering of these new database types.
Yeah, and obviously, as you said, the keeping ACID when it was across machines was most challenging, and then you did eventual consistency and all sorts of terms. But interestingly, is that maybe unlike some other databases that were in this realm and columnar and so on, we do see that the choice with ClickHouse, as you mentioned, also was SQL. So, and it actually very nicely aligns with the trend that we're seeing in the industry. I just came back from KubeCon, where I had a few, like there's a special interest group, for example, for standardizing on queries for observability. And after researching so many languages that are out there on observability, it sounds like the research led to the conclusion probably SQL, or at least an evolved version of SQL, is where they're going to land. So you see that the trend is shifting back. We talked about these trends, the shift back to SQL, because SQL is something stable, it's something familiar, something common across data engineers, developers, machine learning analysts. So it's interesting that ClickUp did the same choice.
There's definitely a lot of tooling around it, and I think that's been part of why SQL has persisted. The other thing is, it turns out I think people underestimated just how good the relational model is at modeling at data. Because this is not the NoSQL era was not the first time that people tried to overthrow SQL. There was a previous era which started at the end of the 80s with object-oriented databases, where people said, and I worked for a company, Sybase, that got caught up in this. There was the SQL model. Everything was tables. It looked like Excel spreadsheets, or Lotus spreadsheets, as they were called back then. And then along came object orientation, which was this new way of arranging data so that data would be clustered around particular types of entities. And people were looking at this and thinking, oh my gosh, SQL tables are doomed, because everybody's programming in this model. We have to build databases that organize it in this way. Well, 10 years later, all the databases were back to SQL again, and all the object-oriented databases had disappeared. They simply weren't as good a way of modeling the problem. So it's a very, very robust language, and I like it because it reminds me of programming in COBOL. It comes from the same era that brought us gems like PL2, ANSI COBOL, things like that. Ada, you can feel it when you're working on window functions. It's like it takes me straight back to the mid 70s.
You've been. I haven't been in that era. I heard a lot about COBOL, but that's a blast from the past. One thing it is interesting is that talking about the SQL, as we said, that is, you brought up a very, very important point. There's a distinction that should be made very clearly between SQL as a syntax, an ANSI, a standard, and the implementation in databases, and where people attribute slowness to SQL, I think that's a problem. Obviously, there are operations like join operations that are very difficult to do when you talk about databases that are more distributed. There are maybe more lax in the guarantees that they give, like eventual consistency and so on. But I think ultimately, SQL as a language, and then I think ClickUp is a great example for that, shows that you can expose the language being SQL and still be very performant. And this is something I think that we can definitely take away from SQL.
Yeah, if I could jump in, I think there's two ways to see that. One important one is I've actually had people tell me that ClickHouse is not a relational database, and the reason is they're confusing it with row databases. That's an implementation. It happens that if you take MySQL and you take ClickHouse, the same database, or excuse me, the same SQL query can run on both of them. It does exactly so. It's SQL, it's SQL on top, but it's completely different underneath. The other thing is that people confuse things like eventual consistency with SQL. So yeah, there are notions of consistency built into the SQL language, but you can still have a relational model where you have eventual consistency. And in fact, ClickHouse is a big proponent of that model, and there's some reasons for it that have to do with the fact that once data extends out to many machines or is processed by many machines, ensuring consistency is really expensive. And ClickHouse always takes the cheap route that is fast when, as opposed to, things that are expensive and require a lot of computation.
Yeah, and again, fast being the operative word, speed, and I think
Yeah.
every discussion that I had around ClickHouse and any discussion with maintainers and with the folks from this community, fast being the operative word. Every time that there's a design decision,
Yep.
an architecture decision or whatnot, speed was very, very clear focus, the North Star of the project, right?
Right. There have been, yeah, I think that has been the principal value in the project, and I would trace it directly back to Alexei Milovidov valuing that above anything else. And I think I think he was and is right, and that attitude has made ClickHouse the database it is today.
Yeah, and again, as you said, it started off in Yandex. I don't know
Yep.
if everyone is familiar, but it's a massive web analytics framework for the Russian, say the Russian Google, I guess, in a way.
That's what they used to style themselves. They, now they call themselves Nebius, but that's.
Yeah, but I'm saying, like, if people want to understand the types of analytical challenge and scale that it was designed to meet, and that, but although it went way past the web analytics, and it's interesting to hear. Can you tell us what kinds of use cases and workloads work best for ClickHouse? What do you see
Sure.
amongst your customers
Yes.
and users in the community?
Right. So Metrica, in other words, an application like Google Analytics that reads weblogs and does web analytics, that was the canonical use case. But even within Yandex, so they used it for about 7 years before it was open sourced, and they were using it for doing funnel analysis on e-commerce sites. They were using it for network monitoring and in fact observability in some form or another. They were using it for log management. What happened was they kept discovering new use cases, and it got more and more widely used within Yandex. And then in 2016, Alexei persuaded Yandex to open source it. And I think there were multiple reasons for this, but one was that I think Yandex wanted to show the world what they had done, that they're a great technology company, just like everybody else. And here's a piece of software, you can look at it, and here's proof that Yandex is in the first rank. So and since then it's just exploded. There's at least a couple dozen major use cases. I think the big ones today are observability, which is why we're having this call today. It's huge. That's probably the number one um, use case, but not the majority by any, but simply the largest one. SIEM, so security information event management. Actually, it's coming up for things like LLM monitoring, which is another variation of observability, and then just a whole bunch of things like gaming, market analysis, so on and so forth. It's a great database.
Amazing. And you mentioned Alexei several times. Maybe a word about the ecosystem. So I guess the biggest player and contributor to the project backing it, which also I guess the original creators and maintainers are now there, is the ClickHouse company,
Yes.
corporate that is the main backer. And obviously Altinity that you presented, the second largest, I guess, maintainers backing the project. Can you tell us more about the ecosystem that?
So it's still very much centered around the core committers for the most part, who originally worked at Yandex, for the most part came over to ClickHouse Incorporated when it was founded in 2021. And so they built a cloud. It works. You can imagine it as kind of being like a real-time Snowflake. So multi-tenant cloud, designed to be simple to operate, hop on, get going. Um, and of course, as part of that, they still have the original team. They still have ClickHouse, the open source database, which they then have continued to maintain. And there's releases every month with longer, sort of monthly releases, and then every 6 months they have long-term support releases. And they've been super active. And one of the things I want to say is that I think that Alexei has one of the things he's done besides himself being a good developer is he's assembled a really great team around him and people that I really respect and whose work demonstrates their quality. But then around him, there's this huge, there's this huge community. In any given year, ClickHouse gets hundreds of merged merged PRs from hundreds of people, participating on GitHub. There are thousands of people who log issues. And there's a bunch of vendors like us who are out in the ecosystem. As I said, we've done hundreds of PRs on ClickHouse, mostly focused on things like storage, security, um, indexing, things like that. Basically, low level features. And then we do, as I mentioned earlier in the talk, do a lot of Kubernetes operations and tools, things like that. And then there's other vendors out there you can find, like say half a dozen different companies in different locations that host ClickHouse as a service. So it's a pretty vibrant community, and I think the biggest thing is just the number of people who are interested in using it. It's grown phenomenally.
Yeah, actually, I looked just before going on the show, and I saw like 40,000 plus GitHub stars. So it
Yeah,
shows the level of interest. Obviously, it's a bit of a vanity metrics, but still, given that
they're
it's
they're
manifested
vanity.
in other ways, not just this, as you said, the active participation and obviously the people using it and
Yeah,
so on. So this is
it's a
definitely.
vanity metric, but you know what? ClickHouse has the same vanity metric as Spark, which is Apache Spark, which is a very, very popular piece of software. They're both sort of around 41K stars. So yeah, that gives you an idea of how popular this is. It's really had a huge impact.
So you talked about ClickHouse on Kubernetes. Can you tell us why would people even want to run a database in general and specifically ClickHouse
Well,
on Kubernetes and then how to do that?
yeah, that's a really wonderful question because when I joined Altinity, it was not at all obvious that you wanted to do that. And there are still a lot of people who run ClickHouse just on bare metal or directly on VMs. But the fundamental reason why ClickHouse has taken off on Kubernetes is ClickHouse is a distributed database, particularly if it's you know anything bigger than a laptop. Once you have multiple nodes, you're talking distributed. You're talking a distributed application, and Kubernetes is designed to run containerized apps that are also distributed. It That's what it does. It orchestrates containers so that you can build complex distributed applications, and just simple things like spinning up nodes, connecting them to storage, respinning those nodes with a larger VM behind them, extending storage, being able to understand, have ways of modifying configuration of passing security information like keys in. Kubernetes just has a bunch of features that do this. So either you use Kubernetes or you reinvent it. And most people don't want to reinvent something that low level. So that's why Kubernetes is kind of one for uh, particularly for people who are building data platforms. It's probably the predominant way that it's run, just like all the other databases out there that have also sort of migrated onto Kubernetes over the last 5 years or so.
So you'd say that today you see that as the predominant way of installing and running ClickHouse in
Yes,
production?
very much so. For production, well, I want to qualify that. It's particularly for people who build platforms. And I'll tell you another thing about Kubernetes that we saw ourselves is Kubernetes has an incredibly good portability story for clouds. So if you run, if you run straight off VMs in say Google Cloud, and you want to port that application over to Amazon, you're going to go through a world of hurt because the APIs that you use for managing storage, networking, VMs are all going to be completely different. And in fact, the whole way accounts are managed and the scope of accounts is completely different in these two clouds. In Kubernetes, most of that stuff is papered over. You have to do some work to glue Kubernetes onto to the cloud, but in fact, the cloud vendors have already kind of done that for you because they all have managed Kubernetes.
Yeah.
So all you do is spin these things up. They cost I haven't looked at the prices lately, but it should be around $10 a month to have a managed. That's the overhead for getting a managed Kubernetes cluster. The rest of it is just VMs, networking, and storage that you paid for anyway. So it's been super successful, and that portability and the managed the vendor managed Kubernetes have been a big part of that.
And interesting to say, because many of the voices that were spoken out against running these sorts of databases, or maybe even other stateful cases on Kubernetes, were like the slowness that comes with the extra layers and the extra virtualization. I think ClickHouse shows, if you say that it runs in production and with the performance that it shows, that you can actually be performant while running on Kubernetes.
Yeah, I think that a lot of that, though, was based on a misunderstanding. The slowness argument. I can't speak for, there's some issues around networking where this is true, where you have overlay networks that may introduce, issues with transfer rates. But Kubernetes, as I said before, is just marshaling containers. Containers are just processes. The overhead, there is virtually no overhead for a container in Kubernetes to access storage. It just works the same way as a process accessing a disk on, on a VM. So as long as the VM is quick, and in general they all are, it's going to be really fast. So I think that argument against Kubernetes, I think, has been shown to be largely a canard. We have never seen any significant difference in performance. What is different is complexity. And a really simple thing and just some things that Kubernetes does that are not good for databases. And Exhibit A is Kubernetes was designed with this attitude that if something is sick, kill it and make another one. This is the
Pets and
cattle.
cattle.
This is cattle, not pets. Just go ahead and shoot that thing in the head. Sorry, folks, but that really is the way the system is designed. Well, it turns out that databases, particularly databases that are running business critical applications, they're a lot more like pets than cattle. Imagine it, because you have processes that depend on caches, for example. They may take 2 hours for the cache to reload in memory. So if you go out and shoot your cow, you're going to wait. You're going to have a really slow system until the new cow comes up and is fully ready for work.
So how did you wrote essentially the way to run it on Kubernetes?
Kubernetes?
So how did you
Yeah,
address with it? Sorry.
yeah. So we're very
Kubernetes operator for ClickHouse. So how did you address these? And
Yeah, well, that's a great question. So first of all, there were some, for people who are familiar with Kubernetes, you're familiar with stateful stats.
Yeah.
That's a resource that allows you to connect a process, to give a process a name you can predict in advance, and also to reconnect it with its storage. Well, stateful sets were, I think, back in earlier and more innocent times, where the idea was they would be there to support databases. It turns out, and gives you an illustration of kind of design issues you have with Kubernetes. Uh, if you use stateful sets as they were originally designed, which is to have a definition that has a number of replicas, it's terrible for databases. Uh, it doesn't have a very good notion of how it does restarts. It can't have different versions of things. It's very difficult to configure the database so that, for example, you might have different resources on one replica versus another. So we made an early decision that, hey, we're going to have stateful sets, but they will only manage a single database. That's really a variation from the model. There's other things that we have to think really hard about, and they have to do with restarting. I think restarts are like the single nastiest problem that we have to deal with ClickHouse. It's still an unsolved problem. So, and then it turns out that there's also some other weirdnesses about Kubernetes. I was sort of surprised to learn that building caching servers that use NVMe SSD turns out to be surprisingly hard to configure in Kubernetes. Kubernetes is really optimized for cloud block storage like EBS, and if you want to use, build like caching servers, which use NVMe SSD, getting those to come up and correctly allocate their storage and turn themselves on in the right order, these things all turn out to be surprisingly hard to do in Kubernetes. So we've struggled with issues like that, or not struggled, but sort of worked around things like that. Those are examples of the kind of things we've had to deal with.
And by the way, we should say, I'm a CNCF ambassador, so I love the example that you run on Kubernetes. It's very, very powerful and fast performant database, and you show this case. And I think many of the points that you mentioned are valid, and I think they're being addressed, just to be fair. I think the latest version, Kubernetes 1.33, had very interesting things like in-place resource resize for vertical scaling of pods, so you don't need to now go through this restart and all the headache. It's still in beta, I think. So don't go run it in production yet, but in the scaling up and down as well. I think it's something that these sorts of cases that have become more well supported within the native communities.
Yeah, I think people are getting out to the margins and being able to, for example, add memory to a running process. Containers can do this, but having it supported inside Kubernetes, that's something, of course, that the APIs have to support it. Being able to make changes to Cloud Block Storage, for example, like dialing up the number of IOPS without having to do a restart or to respin the pod. Those are things that are now possible to do, and those are like big steps forward for Kubernetes, and particularly for databases on Kubernetes.
Yeah, you mentioned a lot of technical detail around Kubernetes and running ClickHouse on Kubernetes. I had the feeling that also ClickHouse itself is a system that you need to know how it works to get the most out of it.
Right.
And it's not given. Some databases are like drop and not much of a knowledge is required for the average user. How would you characterize this aspect of it?
Yeah, no, I think that's a great point, and you're exactly right. You have to know what's going on inside. And I think the way to illustrate this is to follow up on what you were doing and actually compare ClickHouse to Snowflake, which is a great database. Proprietary, but oh my God, the people that wrote it really knew what they were doing. And the thing about Snowflake is that if you know SQL and your boss tells you go write an application, whatever you do on Snowflake, it will work. It might be slow, it might be costly, but it's going to work. So if you're going to pick a single database for an entire organization, you pick Snowflake because it'll pretty much work for everything. ClickHouse is not working. It's not like that. So ClickHouse by default has a 10 gig limit for the amount of memory that you can accumulate in during a single query on a single process. And so as you're aggregating data and doing these scans of trillions of rows or something like that, ClickHouse is going to be happily aggregating, building up aggregates in memory. If you hit that memory limit, your query will just crash. There's no query optimizer that says, looks at statistics and say, oh, I think we better spill to disk because that's, or have some other adaptive or have, like respond adaptively to this. You can spill to disk, but you actually have to explicitly go find the parameter that says spill to disk, and here's the level at which you spill to disk. That's it. So you're talking a lot of under the hood. You're going to be opening up the hood and you're kind of digging under the carburetor and like sort of unbolting the transmission to fix something. It is not like Snowflake. And we often, for years I've always used the analogy of a race car that it can go straight really fast, but if you're doing a lot of corners or something like that, you need to know what you're doing. And these are, just to be clear, these are being sanded off. So ClickHouse, for example, now has a much better query optimizer. There have been improvements in things like joins, which were another, sore point. They were not really needed in some of the early use cases, but these are all things that are incrementally improving over time and making ClickHouse. But I think you still have that thing where you really need to know what's going on in the side, or you need to have a friend who does.
So, and I do think that some who tried ClickHouse without the necessary understanding of that got a bit of a, I guess, friction on their onboarding. So I'm wondering, what's your tip when someone wants to start with ClickHouse to get the right way into the details that, as you said, need to be in the know-how to be successful with ClickHouse?
Yeah, I think it's test it on your own data and test it on a realistic amount. That's the best thing you can do. A lot of problems, this is not unique to ClickHouse. A lot of problems with databases show up when you actually put a realistic amount of data on it. We had this when I was writing apps for Oracle, that there were just a bunch of problems that wouldn't show up until you actually put it into production, because you now had you now had data that was where you might run a query and then go back and inquire something extra about each row. Well, that works fine in a lab where you've got 10 things in the table, but if you have like a million, that query becomes that 100 or 1,000,001 queries become really, really slow. So these are things you need to put realistic data on it. I think that's one of the best things you can do. I think the other place where people get into trouble, and this is not, sort of when you're getting started on productizing, is it can be very helpful. It is not necessary, but it can be very helpful to have a vendor or to have a platform group that is specifically specialized in ClickHouse and takes care of these sort of in the weeds problems, or gives you somebody that you can go to when you hit one of them so you can get it fixed fast. So that's the other thing that to think about. If you're just going to deploy it and load up a bunch of data, you're going to be disappointed, because you will have to learn how it works, and you will have to fix some problems yourself.
And in terms of, so that's more on the, let's say, the first stages, the POCing it
Yeah,
and getting the evaluation. When you move to production, so we talked a bit
yeah.
about it when we talked about Kubernetes, but in general, what kinds of best practices would you share with the users for running it in production at scale?
Yeah, so I think one really big one is to divide your development and your production environments. Again, really old database, paranoid DBA advice here. When you want to test something or you have something that you need to debug, it's really helpful if you can do it in a staging environment, because it allows you to make mistakes. It also allows you to see problems before they arrive in production. So, having sort of a staged environment that you can move it through, that's really important. I think another thing that is really important, in fact, incredibly important, is monitoring. You just get it is as I said, you need to be able to introspect what's going on inside ClickHouse. So monitoring is critical. So if you're not getting it from a vendor offering, you should build it yourself. You can do it in Grafana. ClickHouse is really great at exporting the information that you need. So that would be another thing. And then third thing, think hard about upgrades. ClickHouse has one of the things I love about ClickHouse is you can make schema changes live for the most part, and ClickHouse is really good, much better than Postgres uh, or MySQL, because it doesn't have to rewrite data. But when you are doing upgrades, you want to think pretty hard, particularly when you go into a new version of ClickHouse. ClickHouse changes quickly, and you can upgrade and it can still read the data, but it may change the APIs your applications are using. So again, think hard about that process, and you either do it very rarely and test very thoroughly, or the other way to do it is you do it constantly, but you have a really good way of rolling it back if it doesn't work. So those are staging. Think about upgrades, think about monitoring. You do those three things, you're probably going to be happy.
Sounds good. And I propose monitoring, and what we said before, observability is, as you said, maybe the biggest use case for ClickHouse. And
Yeah,
here at Open Observability Talks, I'm curious to hear about that. And actually, I had an episode just recently with Shopify. I called it the Shopify's Journey to Planet Scale Observability. And it was interesting to hear. My guest was Elijah McPherson, was the engineering director in
yeah,
charge of the real-time storage system. So he's really the manager in charge of all of this. And it was interesting to see that they have made a design choice along with some other tooling that they ripped apart. Vendors. They built in-house based on open source, and one of the choices was ClickHouse. So it's very
Yep.
interesting for the observability. So I'm curious if you can share why is ClickHouse so well suited for observability? For which types of telemetry data? For which types of use cases in observability?
Yeah, that's a great question. And I went and read the transcript of that interview. I know Elijah, and it was actually really great. Interesting enough, we have discussed that system. He had in a uh, told me a little bit about it, but that was a really wonderful description. And what I really liked was the fact that they had sort of creatively mixed ClickHouse, for example, together with components from Loki and other systems. I think the answer to the question that you asked is there's just a lot of stuff in observability that just wants a column store. Logs, for example, traces. These are actually relatively simple data structures. I mean, logs are, they're just, uh, you can express them in a table which has a relatively small number of columns. Sometimes you might have to, have some of the columns might have things like maps, so you can put little attributes on them. But column stores are really, really wonderful for this. And so in general, I think that's why you're seeing a lot of people who are building systems, particularly very large ones, are picking ClickHouse to store particularly logs and traces. We also see people storing metrics, but that's a little bit different. Um, so metrics, and if you go, look at OTel, for example, um, it's kind of hard to, metrics are a little bit harder to model as tables. And so OTel, I was looking at the code, and I think they model it in 5 different ways in the ClickHouse exporter. So they have like histogram metrics, gauge metrics, things like
Rate
that.
and count and all the
Yeah, and it's kind of awkward because like then the value that you're measuring can be a string, and then you have to do conversions. It's a little bit tricky. So for that, when people are building large systems in particular, they either use some generic modeling, what I just described, or they just say, oh, the thing that I'm collecting data on is a CPU, and there's a bunch of standard things that I want to monitor there that come off IOStat. I'm just going to make a table called IOStat, and it's going to hold them as columns, and it's going to be, and I'm going to do this for each kind of entity that I monitor. If you do it that way, actually, ClickHouse works brilliantly. And the cool thing there is you then end up having one database that holds all your data, regardless of the type of observability application you're doing. So you just have to learn one thing. But I think the core answer is observability generates a huge amount of data. You want a column store, and the other thing is that you want to be able to, when something goes wrong, you want to get to the bottom of it really quickly. Usually, usually when systems are down and or they're performing slowly, your users don't tell you, "Oh, this is great. Just get back to us next week." They say, like, "Look, the business is down. We're blind. We need this solved yesterday or like 10 minutes ago." So you want something that can scan the data really fast.
And we talked about the ecosystem, so I think interesting to talk about the integrations that make ClickHouse native to observability systems
Yeah.
around them. You mentioned a bit about OTel, OpenTelemetry, for those who
Yeah.
know. We talk about it a lot in this show, and we mentioned Grafana. So tell us a bit about the integration ecosystem around ClickHouse.
Sure. And I want to preface this by saying I'm really not an observability person, but I think, the two, in fact, Elijah's system I thought was really great because it did illustrate two of the really big movements in observability, which are of course Grafana, which has just built some wonderful components
Yeah.
for things like Loki, for example. We use it ourselves, and in our cloud service, it's very powerful, has excellent query capabilities. Then and then OTel, of course. So OTel is cool because it's standardized a lot of things about telemetry that used to be little pieces that didn't really fit together very well, like collectors and things like that. So we see very, very broad adoption of OTel, sort of for the mid-range systems, I think you might call it. Because for the little ones, you can just go. So, for example, you can use Loki, and if you're operating on a small scale inside a ClickHouse cluster, you cannot you cannot build a system as efficient as Loki using ClickHouse. We've tried. It doesn't work. They did a really good job of engineering that. On the other side, when you get systems that are very large, then they kind of outgrow. OTel, particularly the way that the OTel exporter works in ClickHouse. But for that middle ground, it's pretty popular. And then I think people just tend to mix and match to get something that works for them.
And just to understand, so we talked about Shopify. Give us some more known companies that base themselves on the open source ClickHouse, just to understand what kinds of companies you made this choice.
Yeah, so I have a hard time doing that because some of the companies I know, I'm not sure whether I'm on a whether I can talk
Commercial
about them.
version or the open
But
source.
I think a good one actually that my colleague Josh just posted, which I think is worth mentioning, is Cloudflare. So Cloudflare has they were one of the earliest very heavy users of ClickHouse. Still have one of the largest installations around. They use ClickHouse for practically everything. So there's a lot of observability that's going through ClickHouse. I don't know whether how far they've gotten onto OTel. My suspicion is most of their stuff predates OTel. There's things like Quarian, which is from Lorenzo Mangani. That's kind of an interesting product to look at. That's was based on ClickHouse, but I think is moving somewhat more in the direction of DuckDB. But there's just a bunch of people who are using this technology. I think that it's fair to say that about half the people I talk to who are doing an observability application have OTel in there somewhere, and they may not use it forever. They may not use all of it, but they start there because it's now become kind of a standard, and it's something you can just grab off the shelf and get started on.
Interesting. And I wanted to talk also about your new baby
Future,
open source
yeah.
project.
Let's say,
Project Antalya, because it
yeah,
seems like we talked at the beginning of the conversation about the
yeah,
trend in
yep,
databases, and one of the interesting things is that the big data challenge, and it's also something that was prominent in why ClickHouse, right?
yes,
But
exactly,
now data grows,
yeah.
so people
And
looking for ways to leverage
yeah,
data. So tell
what's,
us a bit about this journey.
yeah. So in one sentence, data sets are outgrowing open source ClickHouse. And this is like a kind of a shock actually, because when ClickHouse arrived, it was so much, it compressed data so much better than MySQL and Postgres, that you could actually store these enormous data sets and not feel the pressure of the cost of storage. That's changed. So when we started, or at least let me put it this way, when I started at Altinity 6.5 years ago, we would sometimes get, we would get data sets that run into tens of terabytes. We now have people that are putting in 2 petabytes a day of data into their observability systems. These are completely overwhelming ClickHouse. And what's happening is even mid-range systems, you might have a system that has, say, 200 terabytes of data. If that's stored on block storage using the existing open source ClickHouse model, you're probably going to have multiple replicas. So you're going to take that block storage cost. It's not cheap. It's 10 cents a gig per month. You're going to replicate it 3 ways. So you've just created something that's now over 10x more expensive than storing it on object storage, which is actually what the Loki guys do and why their stuff is cheap and very efficient. And this is overwhelming ClickHouse. So what we are doing is adapting ClickHouse for the next generation of systems, starting with observability, but including all these other use cases that have growing data. And we're going to use Iceberg as native storage. And I think this is a timely, like a really important time to do this, because people are, the practical effect of having these big data sets is they're costly. So people are now looking at their cloud bill, and it's 60% of it is storage. It shouldn't be that way. The other thing is that if you move to something like Iceberg, which is shared object storage, you can also make compute cheaper. And the reason for that is because everybody can see it. You can now have compute which scales up and down. We implemented that as what we call swarm clusters, which are just stateless clusters of ClickHouse that will scale up and down and be able to allow you to allocate as much compute as you need to run queries on your data out in Iceberg, and then when it's done, you can dispatch that compute, and you're no longer paying for it. So this is a really important transition. It solves like just these two basic practical problems: lower the cost of storage, lower the cost of compute, enable people to build systems that now can last for another 10 years.
Nice. And again, it's very well aligned with what we see in the trend
Yeah,
with data lakes and the patterns that you see with other data stores and solutions. And Apache Iceberg, again, being an advocate of open source, this is a very, very solid
it's a
open
great,
source, very vibrant community.
yeah,
So a good pairing and matching here between these two open source
yeah.
projects.
And I think what's the other interesting thing, and it's not like this idea of using shared object storage, that's not new. The Snowflake folks uh, came out, they were working at Oracle, but they lit on this idea now 15 years ago, and they implemented, but it was proprietary. The thing about Iceberg is that, as you're alluding to, it can be shared. And this is a completely different, what we're doing is also entering a world where the data is stored centrally and the applications all independently access it to get work done. And that's why I think that choosing Iceberg now makes a lot of sense, particularly as we see people like Amazon converging on things like S3 table buckets, which have Iceberg support essentially built in. This is the way that people are going to be storing data, and so you want analytic databases to be able to work to treat it as native storage. And
Yeah.
it's a big challenge, but it's the coolest thing. That this is the coolest project I've worked on in my career. So, and it's really, really, because these storage changes, these big problems come along about every 10 or 15 years. And so we get the joy and the heartbreak of working on this next transition. So it's fun, and I hope people will come try it.
Yeah, it really was launched just the other
Last
week, so
month.
it's really
Yeah.
fresh last month. So hot
Yeah.
off the press for our listeners, and go check it out. I did put the for folks here on the live stream the link to the launch blog, so you can read more about the announcement and get all the details, the diagrams, the architecture, and obviously the links to the project itself. And for the folks on the listening on the podcast, it'll be on the show notes as well. Don't worry about that. And also important to say, it's an open source project, Apache 2 licensed. And
100%.
what's your plan for this project? Is there a call for action for the community to join in?
Yeah.
What's your opportunity now to approach the open source enthusiast in the audience?
Try it out, break it, help us fix it. That's the three things that you can do to make this thing great. You're absolutely right. It's 100% open source. So the way that we approach actually anything related to ClickHouse is we believe ClickHouse should be 100% open. In fact, the building blocks of analytics systems should be open. Our business is to help people run them, and we have proprietary software that sits on top of it. We're profitable, but underneath what people have is this open source software, and I think we can see this elsewhere where powerful open source components have enabled people to build very, very creative and world-changing applications, and so we hope this software will be part of that. And we'll just ride the tide with we're of course our cloud will support it, so we'll have fun. But it will also enable us to, it's interesting because by running it in a cloud, we're not just making money, we're learning more about it. We can put that into the software, we can help advise people and create something that's more robust and able to do more things.
Sounds good. So as I said, I will put the links, and for the folks in the audience who are interested to check out the details, they'll have all the links about the GitHub repo. And is there like I don't know, a Slack channel, a Discord, a
There is,
place
yeah.
where
Just come to the Altinity. Altinity DB has a public Slack. Just come to altinity.com and punch the button and join us. And yeah, we love to. I don't know if you could tell, but we kind of like databases. So just come and talk, hang out with us. And if you know C++, stick around. That's so, or Rust, actually. If you're a Rustation, we would also welcome you as well. There's good work to be done. So I hope your listeners will join us.
Yeah. So definitely for all the listeners, do check it out. An interesting project, and also of course check out the ClickHouse project itself, and all the vibrant community around that. Robert, thank you very much for joining me, and I want to wrap up with a few industry updates or community updates, as I always do on the so stay with me and maybe you'll have some commentary on that very briefly. So first of all, I mentioned Kubernetes 1.33 that was released. I shared a link with some of my highlights, and also the link to the full release notes. You have cool things such as the native sidecar container support reaching stability, the what I mentioned before, the in-place resource resize, for vertical scaling of pods, and support for user namespaces with within Linux pods and all of that. So do check it out. Really nice work on this release. Another thing, we talked about databases and storage. So OpenSearch storage reached a major release, version 3.0, just I think 2 weeks ago, if I'm not mistaken. Very interesting there. Again, both on performance, both on features. The vector database side of house gets boosted. So check it out. I'll share the link on that as well. And maybe a last one, we talked about open source here quite a bit on this episode and in general. So worthwhile noting a new permissive license for machine learning models announced by the Linux Foundation. It's called OpenMDW. So I'm also sharing the link, openmdw.ai. Very interesting, because this has been a hot topic of discussion in the industry for over a year now. I had a dedicated episode about what's the relation between open source and AI, and what is open source AI. We had it with Stefano Mufelli, the general director of the OSI, the Open Source Initiative, the guardian and champion of the open source definition. So interesting to see how the community evolves with trying to figure out what exactly is open source in the sense of, in the case of AI and machine learning and all of that. So check out, very, I think it was just released a few days ago. I need to delve far more into that, but very interesting to point out. That's all that time permits for this time around. So Robert, again, thank you so much for joining me on this episode.
It was a pleasure. Thank you so much for inviting me.
Yeah, and thank you to all our listeners out there for joining us on this episode. As always, all our episodes are available on all the podcast apps, wherever you get your podcast, or on YouTube. So do check it out. And if you are now listening to that on one of these, do know that we also live stream the episode. So follow us. We are on X, on Blue Sky, on LinkedIn. So follow us for the live stream times, and then you can join, ask your questions, chime in with your insights and comments. So a great opportunity for everyone else. And until next episode, which will be, by the way, about OpenSearch 3.0, the major release. So we'll dive into that one on the next episode. Until then, thank you very much for listening. And as I always say, may the open source be with you.